Howdy, folks. So howdy in the chat there. Be kind of curious where you guys come from, as far as like if you found me on the Reddit or the multitool.org forums or just randomly on YouTube. Then we can get started. So if you don't know me, I've been making for a few years now a bunch of accessories for the Leatherman products. Specifically holsters is what I kind of started out with, and I designed one for the Leatherman Wave. And now I think I'm up to 7 different Leatherman tools. They have holsters, and then the thing that I'm becoming a little more famous for now is taking the free series and modding the heck out of it. Scalpel holders, blade, T-shank holder, and then this, which allows you to use your new Leatherman Ratchet driver with the Leatherman Free series, which is the flat bit holder. Some of you may already have these. I'm not sure. So by trade, I am a mechanical engineer, and actually kind of electromechanical engineer. Went to school for electronics, and taught myself mechanical engineering. And I built these, like I said, I built these things initially as a way to get myself a holster because I carried a Leatherman every day, but I really hated having it in my pocket. And now it's kind of grown into a whole little thing where what I plan on doing with a ratchet is building a very accurate 3D model of this, similar to the way I've done the Leatherman Free P4. Let's see if I hide these guys here. Oh, look. So like this is a rendering I made of the Leatherman Free P4 after I took it apart. So this is how accurate I make my 3D models. Every little detail is in there. And then that lets me make my accessories have basically a perfect fit to the parts. All right, so if you haven't seen the Leatherman Ratchet, I figure some people are going to want to be able to actually see how it works. I've been, of course, playing with it, but put it back in the box for the video here. So it's actually the exact same length as the existing, they call this the bit extender. And then the bit extender is really nice because you'll pull this guy out here, and then you have a much further reach if you need to get down into a hole. Also further reach if you need to do some leverage on it. Whoops, I'm a little off camera here. Sorry, guys. And then the other thing that I like actually using it for is basically a screwdriver all by itself. And then now, of course, the Leatherman Ratchet just adds that ability to, that ratcheting ability straight into there. With a middle detent and a, of course, ratcheting in the other direction detent. I'm real excited about this. Probably even when it was leaked on Reddit, I already had people asking, am I going to design a holster? I have a holster design that holds this guy in place, if this was going to be compatible. It's obviously not because it's much thicker, so it's just simply, it can't get past the grip that I have at the top there, so that if you ever snag this, he doesn't rip out. So I'm going to maybe work on a design. We'll see where we get to. That's part of the reason to build the 3D model. I may end up doing a holder that holds this guy all by itself on your belt with flat bits and maybe some regular hex bits so that you can carry whatever you want with you. And this might be a separate holder all by itself, because if you ever played with these guys, these are the Leatherman flat bit holders. And they work pretty well as far as the stuff comes, as far as them coming out. I have bit holders on the back of my holsters, and they are much harder to take out. You kind of got to push them out with a tool. I did that deliberately because I don't want to actually lose these. But in either case, it'd be kind of cool to have something that actually held all this together on your belt, so it would be ready to use with whichever tool you're going to use it with. So this is not compatible with the Free series without a modification. It is compatible with the Leatherman Charge, Surge, and Wave. All right, so what we're going to be doing here is I have Solid Edge. Now, Solid Edge is something I use professionally. This is not SolidWorks or Inventor. You're going to see Inventor a lot on YouTube now because they've gone with a freemium sort of profile for hobbyists. They're kind of doing a bait and switch for a little to a little bit of a degree as far as same thing that Eagle CAD did with PCBs, which is get everybody hooked on the free version and then start charging them for it. I use Solid Edge through my work, and it is to me light years beyond what you can do with most other kind of CAD programs. It has this mode called Synchronous, which lets you build things without having to have that sketch-based history behind your design. So this is actually the 3D model I have for the existing holder, the bit extender. What I'm going to do is actually start from scratch, but I just kind of wanted to show what this is going to kind of look like in the end. I might open this file up and steal some dimensions that I already have, so I don't have to bore you with every little caliper dimension. But I kind of want to show the process of how I go through this 3D model, how I develop these products. If I open up one of my larger projects, like the Leatherman Free, give this a second here. I meant to actually have this open ahead of time. I'll actually go through, and with the holsters, there's multiple combinations. So inside here, I'll actually have multiple bodies that I can either Boolean together or take apart in order to actually build all the different combinations of holsters, and then the ratchet will be a new version of that. See, so you can actually see the number of components that are inside this 3D model. This is to generate renderings and all sorts of other stuff. So these things aren't actually as simple as they look. So these are all the different combinations overlaid on top of each other. But if I do just the free P4 by itself, it goes like, you can see how detailed all the way down to the filing inside here. Oh, sorry, I'm not watching the chat. I'm just talking my way. Let me look at this real quick here. Yeah, so OpenSCAD is really good for anything you can do that's parametric, where what that is everything is driven by actual either a sketch or even a spreadsheet, and it's really good for that kind of thing because you could scale stuff. It's a little bit harder to do something this complex. And then somebody asked why I'm using SolidWorks. Like I said, I'm using Solid Edge because this is what I get through my work. I use this at work to generate things that have tens of thousands of components inside them, which most other CAD programs bog down on. Solid Edge has an automatic level of detail and complexity converter that basically allows you to have incredibly massive detail without losing speed and performance. So I'm running this on a regular graphics card. And then somebody asked about Shapeways. So Shapeways is so they're a 3D printing company. What they do is they 3D print. So just this part here. This is mine that I use personally. You can see how it gets dirty and it gets used. This one's a little more less used. So Shapeways is a 3D printing company that allows you to upload your designs and get them 3D printed, but they are very high-end 3D printing, the stuff that you can't get at home. So this is made with laser-sintered nylon. So this is extremely strong, durable. You compare it to what you get at home 3D printing, you can't, you couldn't take a PLA piece and bend it like this and have it come back. It would just snap. It's also solid. So I'll make all my products using this, or these guys are actually these are actually a adhesively binded stainless steel powder. Then in a sintering process, they replace all the binding agent with bronze. So this becomes out 60% stainless steel, 40% bronze. And this becomes an extremely strong part, strong enough to do all of the metal bits that are needed here, such as having these little bit of spring that's in there. And I've had this torque tested, and have details on the multitool.org thread showing how strong kind of this bit driver can be. Strong enough that the body of the tool starts to split. All right, so let's get back to the ratchet driver. So you can see I actually built this one with fairly few features. If you're familiar with CAD, you're going to be like, where's the sketches? Like again, you'll see the process that you use sketches to build the part, but then you don't need those sketches later. The nice part is that that allows you to work with anything that you imported, such as say screws from McMaster, where I want to modify a screw or uh, as needed to kind of form these custom ones that Leatherman uses. It allows you to work with geometry that you don't have to worry about the history of that geometry, which is something I absolutely love. It's almost kind of like sculpting. All right, so we're going to head and start with a whole new file. Now I'm going to work in inches, but you'll see me measure sometimes in millimeters. I know that Leatherman designs in inches and sometimes millimeters. After getting into the P4 here, so much of the P4, not the short on that camera, I got a camera over here. So much of the P4, like all the thicknesses of all the blades and things are on perfect inch increments, but then every once in a while, like the distances between these dots are metric, and so they sneak in a few things, but the screws are in inches, so we're going to be working in inches. I can work in either one. I've worked in both worlds, depending on where a product needs to get made. All right, so I'm going to switch over to a split screen here. So I got the calipers up here and solid edge over here. And then these are not the world's best calipers. These are TacLife, the cheapest calipers. They had a big screen from Amazon. I use the much better name brand ones at work. But this is what I bought myself. So it's been accurate enough for what I've been doing for this. I only need to be accurate to about 0.1 millimeters in order for the accessories to work well. So, the first thing we're going to do, of course, is measure the outside diameter. So I got 10.36 millimeters. But here you can see, all right, maybe it is 4.0 and a hair, 4.08. And that's where I kind of have to toggle between millimeters and inches depending on what they actually used. Check. No, I did used to have a Harbor Freight one. I probably still got one in the garage that I use. All right, so we'll go for 0.0. Let's go for 0.048 for give us a little bit of tolerance. Wait, 408, yeah. So I'll type 0.408 in here. Hopefully that's going to be big enough. If I need to, I can try to increase the resolution of this a little bit. So I start out with a circle, of course. Anybody's done CAD, this is kind of how you start out. And then we'll draw this down. And in this case, what I'm going to do is go to, let's see if I can get closer to the camera here. Actually, what I can do is zoom in. And let's refocus. So I'm going to, sorry, I'm looking at the, making sure that I'm in frame here. I'm going to go just to the shoulder here, and I'm going to again switch between millimeters and inches to kind of see where the designer picked. So I'm guessing it's 0.997. Might be 0.96. You also eventually you gotta learn your fractions and which, if somebody started designing things on fractions. So far, most of the stuff I've seen with Leatherman, they design on a 1/10 or a 100th. But that actually might be 24.6 millimeters. So let's go with 24.6 millimeters. So in here, even though I'm working in inches, I can type 24.6 millimeters, and that'll extrude down 24.6 millimeters. The next thing we'll just do is the body, the secondary body. We won't worry about all the little details till later. So secondary body is, zoom out a little bit so you guys can read the calipers. Wrong button, wrong control. So 8.52, jump over. So it looks like they might have designed this in millimeters because it's not coming onto any nice whole number here. So let's go with 8.5 millimeters. And if it gets down to the project and I notice that almost everything's metric, I'll just go ahead and convert my units inside the program, inside Solid Edge. So in this case, I'm going to jump from the shoulder to the top of the ratchet mechanism. And measuring with the back of the calipers here in order to go point to point. Trying to find just the very shoulder of that transition. And one thing I actually do sometimes when I'm doing this type of caliper measurement is to make sure that I can't see the screen while I'm doing the measurement, because you'll find yourself, you'll push yourself, right? Where you'll go, well, I think it's this. I think it's 16 millimeters, and you'll jump right to that. And it might be where sometimes if you work on the backside and aren't watching it, you'll flip it over and go, okay, maybe it's 16.3. So let's go with that. Yep, quarter inch, 6.35. That's one of the things you end up memorizing. Memorizing all your eighths, sixteenths, 30 seconds sometimes, depending on what you're working with. I do like working in millimeters more. Most of my personal projects, I work in millimeters. All the holsters are designed in millimeters. That's because I really like it that your tolerances are much easier. Your tolerances are 0.1, 0.2, 0.3 millimeters. So then your numbers end up being 0.1, 0.2, 0.3 differences, and you can literally go, okay, that's a 15 millimeter hole, and that's a 15.3 millimeter hole, or hole and bearing inside, and then you can figure out what your tolerances are. Where when it's in inches, you got to go, okay, was that 0.875? Now is that 0.8758 or is it 0.8759? You get down into the hundredths, but it's actually some fraction that somebody picked mathematically by adding on a couple hundredths, and I don't like working that way if I don't have to. All right, next part, of course, is going to be the big body. Here we go, 14.99. So now this kind of makes me suspect that, well, there's a couple of things. I've seen this ratchet mechanism before. I meant to bring it out. I have a very small ratchet driver that has almost this exact look to it and almost this exact same size and difficulty actually ratcheting it. So I'm guessing they went and found a product that already existed and asked that company to kind of shoehorn it in. And then the fact that this comes out to 14.99, so 15 millimeters, means that somebody else probably designed the ratchet mechanism. Maybe they even just reuse the same plastic. We'll see. All right, so 15 millimeters. And at that point, that's exactly where I'm going to go ahead and change my file units to millimeters and just be done with it. Of course, all my dimensions that are stuck here. Now, anybody's worked in CAD knows you got your driving dimensions. The things with Solid Edge, I don't need those dimensions. What it's doing here is taking all the sketches of the circles and putting them in what's called used sketches. And I can bring any of those back if I need to, but none of those sketches are driving these parts. In fact, these parts are all being driven directly. And so I can literally just click on this at any time and change the diameter. Now, some other CAD programs do have the ability to do that. They have the ability to change some live things, like grab this edge and move it 10 millimeters or something. With Solid Edge, I can actually do things like this is going to sound like a sales thing for Solid Edge, but I don't think it gets enough light out there, or enough time in the spotlight. So I can do things where I have these two dimensions, and then I could actually mathematically attach them together, and it would actually drive. These dimensions would drive this 3D geometry. It doesn't need a sketch for that to actually happen. All right, so now we got our ratchet piece. I'll bring that down. And in this case, I am going to try to figure out how big this black or the plastic piece is here. I want to leave that little bit of a gap so that this ends up looking correct in the end. So I'm actually going to kind of catch the hook there. Now I can't get all the way to this body, so what I'm doing is looking at this as straight on as possible so that I'm kind of trying to get this to the point where I think it's on the right spot, so that I am catching this top shoulder with my dimension. What I'll actually do is use my computer monitor, or I'll hold up the piece. See if I can get it in camera. where I kind of look through the use the monitor as a backlight and use one eye, and you can kind of get you can usually get pretty darn precise doing that. So let's go with 13.6. And then I'll add in the rest of the features to this later. Now I want to skip a little in the middle, and I don't really care what that dimension is going to be. So let's add just a little bit for our little tolerance. Let's call it 13 millimeters. And this is going to be our gap. And I might be able to measure that. It's just coming out to 0.22. This is again where I'm kind of trying to do it blind. It's not 0.07 for sure. It's got a little bit more than that. So let's call it 0.2. And that's actually pretty typical of a slip tolerance where you want two things to kind of be moving around past each other. Now I'm going to assume that this guy's 15. And we're going to again measure from the corner, and we're going to try to find the shoulder of this where it starts to go around the bend. Now there's a little bit of a radius, which makes it a little tricky to do. I'm going to guess it's either 2 or 2.2 millimeters. Let's go with 2.2. Sometimes when you're doing a 3D model of something like this, you can end up finding where everything falls on an exact millimeter number. And then you can just kind of almost see where their tolerances were, or if the designer decided to pick everything on tenths. So again, now we're probably jumping back to an inch thing here. Let's see here. It's probably equal to the other guy, actually, now that I think about it. No, he's not. He's a little different. 8.5 for that part of the body. Maybe 9.5. Let's go with 9.5 and give ourselves a little bit of tolerance there. This is also me trying to push it where I don't want hundredths of a millimeter accuracy in the first place. When I go to design around this, I want to be able to have my offsets and things be nice, even numbers. So trying to get to the corner of the inside and then trying to find that edge there. It's a little bit hard. We're probably going to call this 4. And let's go with 4.2. All right, now we got our hex. So Leatherman's flat bits all have the same profile. If the camera will focus, it might get a little noisy here. Camera's got an autofocus mode, but it likes to bounce when I get stuff too close. Where's my camera view? There we go. So like they have a little middle portion, and they've made that equal for both the flat bits and for the bit drivers. And that's nice because it makes it so that when it fits in the tool, the catches that grab these back edges fit in just the right spot on the actual tools. So I could just go and grab this from, like I said, I got this little profile here and it's already done, but that's not what we're doing today. So in this case, the sketch is going to be a little bit different. We're actually going to start with a hex, and we're going to assume 6 sides. We could assume that it's 6.35 because it's on inches, right? But the thing is that, so let's go and grab a 1/4 inch bit, and it is 6.35 on this guy. Now, this guy's going to be a lot harder to measure because I can't just squeeze it, it'll start turning on me. So we can either assume it's 6.35, 1/4 inch. Maybe what we're going to end up doing here. What I'm trying to do is torque against the calipers while squeezing the calipers to try to find where the flat is. And it's coming out to 6.3 something, so let's assume that's 6.35. So now in here, it's going to be, so let's do 0 degrees, 6.35, but this is actually radius, so we're divided by that by 2. Oh, and see here my sketch, I accidentally missed the center. That's easy. We'll grab the move tool, select our sketch, find our center there, and move that there. Now, even though this sketch has got like, if I extrude this out by itself right now, it will actually develop the polygon relationship so that I can resize this without worrying about, I don't need the sketch to drive it, but it still knows that it's a six-sided relationship, and it can do that with all sorts of things. But instead of extruding that out right now, what we're going to do is make our flat inside of this sketch. And that measures out to, let's call it 3.1. Yeah. And I don't have to worry about where the rest of my sketch falls. All I need is this middle portion. Now there is rounding on here, and we'll add some of that later. For now, we'll just go ahead and develop this. Now, instead of pulling this out and trying to measure the distance, what I'm going to do is go ahead and do end to end, because this is a dimension I can get very accurately off my calipers. Let's call it 82.6. Now, again, this is something you can't really do in other software, which is just go ahead and delete all my sketches. I don't need those sketches, and I actually don't even need the dimensions, because I can go through at any point in time and just instantly re-add the dimensions back, and then they become driving dimensions. All right, so now we're ready to start doing some of the detailing here. I guess the first thing to do is actually save the file and make sure that, oh, let's see, 1 second. I'd already decided I was going to maybe copy this guy. We'll close him and save over that file. All right. So I think the first thing I'm going to do is add the cutouts in the hex at the back here. So I'm going to start a sketch from the side this time. Grab that corner and just start dragging over here. Type in my angle, then that way this is just one dimension that I have to alter. So I'm going to grab the end, and again, trying to find the corner, because that's going to have a 45-degree angle on it. And let's see here. 15.6 doesn't come out to anything even in inches. 15.6 or 15.7. Again, this is something where I always got to hold it up to the light. Let's call it 15.7. Kind Anon asks if it's profitable selling on the Shapeways based on the time I spend building the 3D models and prototypes. In some cases, yes. In some cases, no. I do make a couple $100 per month off of Shapeways. It varies quite a bit month to month. And then you got to pay taxes on that, of course, too. In some cases, such as the Leatherman Free series, I've made quite a bit, and that is the most popular product. But then I've invested money and time into the Leatherman P2, which is less popular than the P4. But then the Surge, the Wave, the ST300, the Charge. I have waiting in the wings, multiple Leatherman products, such as the Raptor that I feel like I could do a better holster on. Developing these type of products, like the T shank holster here, took like 6 months and several $100s of prototypes to build. So if it's popular enough, I make that money back fairly quickly. But some of the other products, like I didn't do the ST300 till about 5 or 6 people had requested it. Only 2 people out of the 5 or 6 actually bought the holster, even after I said, "Oh, it's available." And so the ST300 sold 2, and that's still I don't make the CAD models and call it good. I 3D print, I order these parts for myself and make sure that they fit and work. And if they need tweaking, I tweak them until they have this nice, perfect snap and click and all the right features. And I develop them in lots of different things. So it is lots of hours of work, but it has paid for a shed. It has paid for some fun toys. Actually, the camera that I'm using for this. I use it as my hobby money to cycle back into this, and also making props, which you'll see on the rest of my channel. And it's just fueling my kind of fun money, and that's what I use it for. But it can be. It depends on what you're doing. Shapeways itself, unfortunately, is a little frustrating sometimes. As far as a company, their marketplace is kind of hard to find, so you kind of got to advertise for yourself. The cool part is that my company has a Fuse One that will be here next month, and I will be able to make these SLS parts myself. Once that happens, we'll see what I'm going to end up doing. I might end up being able to put all these on Amazon. We'll see. I'm reading some questions here. So Chris Swanson, thank you. All right. So like I said, this guy had a 45 degree, and I went to the bottom corner of the 45. So what I'm going to do is just come in to, basically, it looks like they went just to where the flat meets. And then I'm going to jump back, and I can hold shift, and that will lock to a 45. Now, some cool things that I can do here that makes it difficult in other CAD programs is having open-ended sketches, where I can subtract these edges. I can take this, or actually I can show you the mirror feature later. So now I can extrude just this chain, and it doesn't matter if it's open-ended, and I can cut that off. Then I can grab that, mirror it about the Z-axis, and it flips to the other side. In this case, it did fail on the mirroring, probably because of the open connection over here, or the peak. So again, that's where I can just bring my sketch back, grab this, flip it on both sides. I'm going to be a little lazy. I want this to just be one cut. So what I'm going to do is draw an extra line, bring these corners up to that line. Actually, I'm going to switch over here, just zooming in a little bit for you guys. And then I go back to the extrude program option. It's still an open-ended sketch, but this time it's open-ended all the way around. It's going to drop a dimension down for how much it cut. I don't need it, but we have that cut. And then, of course, the other end. Yep, now I've switched off my screen here. Let's switch over straight to the camera. The other end of this guy is actually rounded, not at a 45, where this guy is rounded, or is at a 45. So the rounds get a little bit tricky when they're this small. You basically kind of got to guess them. You could try to get in there with your calipers and try to find the edge of the round. This case is coming out to maybe 1.5 millimeter or 0.05. They might have picked 0.05 inches. I'm going to assume they worked in millimeters, since a lot of the other pieces are. So let's call it a 1.5 millimeter. They might have picked a 1/16 of an inch, which is 1.6 millimeter. And then what I can do here, since this has got a peak, I can't use the regular round function because it's not got a flat to work with up there. Oh, sorry. Don't have solid edge. There you go. This is my first stream, guys, and I got OBS running, and it's getting tricky to kind of learn it. I need to get some keyboard shortcuts set up. So I can grab these two edges. I'm actually going to grab this edge further back here. And it's got a 2D round tool, and it'll just start dropping it down. And in this case, let's go with 1.6. Let's assume they did a 1/16 of an inch. This might even be hand ground. And in this case, we're just going to cut it like this, erase those other two lines, mirror it to the other side. And these are already filled profiles, so I can just grab them both. And it'll automatically try to figure out if you're going to subtract or add. You can just hit the space bar and subtract and add. So that feature's already there. There's some other kind of, it looks like they softened the peaks Switching over to the GX. Looks like they softened the peaks here. Focus. Come on. Well, you can kind of see it in the reflection. Because you're never going to get a perfect hex. It's going to get worn down, so it actually looks like they machined it in a way that it was a little bit worn down. So for that, we're going to go in and just add a radius, probably 0.5 millimeters. Doesn't really matter once it gets using the tool a few times, it'll just get worn off anyways. All right. So now we're starting to getting into some of the smaller details. I'm holding the wrong thing. All right. So they machined in this part, because it's probably got some complexity inside. I've noticed that Leatherman is using less and less machine parts and more sintered parts. If you look on the Leatherman Free, these spring guys that are here, these appear to be sintered because they have just so much complexity, and in some cases they don't have any inside radii that would give it away as being machined, compared to say the pliers, which definitely look like they're machined. So they're probably actually sintering these parts, which allows them to get some different unique geometry, and but softening this, if they're actually injection molding this metal, which is a thing now, then it might be why they got so many rounds kind of applied to it. All right, so let's see here. There's going to be a 45 here, and then this looks like it might be a 30-degree chamfer. And so what we're going to do, we can go into Solid Edge and either just apply a 45 straight to this guy, and we can kind of figure out what the dimension is going to be by trying to measure that with the calipers. It's a little tricky because it looks like they chopped it off a little bit. Trying to find the centers of each of the rounds. Let's go up 1.7. And by chopped it off a little bit, what I mean is right here, I can see this flat on the actual part. And in this case, I'm going to grab this face on both sides. I'm going to turn off the design intent. Design intent is what allows it to automatically do some symmetry and things. And I don't want it to move the other flats. So we'll just pull that up and it will automatically kind of erase itself. And that's actually pretty close to what this part looks like. There's a little bit of a basically round in here and in here. There's actually a round in here. The catch is that these are not quite what they look like. Trying to look at this visually and see where you look. So I'm looking at the reflections to try to see where the different rounds are. I might actually need to round off some of these other edges in order to make these kind of fly. For the most part, it's again getting down to the minutia of what's in here. All right, so for this 30 degree, we're going to do that with a sketch. So I'm going to grab a side profile, jump off that corner, hold shift, and I can just get down to a 30 degree. And all I really need to do is make a triangle, grab that surface, and revolve it around the center. And it's going to try to go to erase mode. I hit the space bar, and it's going to be 360. Now, actually, you might have done... I got something wrong here. 1 minute here. Because that is not matching this profile. This little base is a lot longer. Oh, I see what I did wrong here. Okay. Definitely got it. So this is where I can actually show you. So we'll go ahead and put this feature back in. And now I can update this without worrying about going back in the history. So if I screwed this up and I was doing this in a history-based program, now I got to go back to my sketches, sketch number 3 or 4, or whatever it was that took to do this dimension. I think what I did is I screwed up this dimension right here from the base because there's a little bit too much. There's too much space in this area. So what we're going to do is going to measure that flat to that flat, which I can do with the calipers. And we're going to tell it I'm going to drag all of this face with it. Yep, so I got that off. That's 63.9 maybe. Let's try the other side. It's got there's a little bit of compression because of the ratchet mechanism, so let's call it 63.8. And voila, now that looks right. I don't need that dimension anymore because I can drop it in just as fast if I need to later. And this is I'm not building this parametrically where I need to alter the dimensions. Let me catch up with chat here a little bit. Yeah, I'm actually curious how much this ratchet can handle also. In torque, can't afford to necessarily buy two and break one. What it probably has in it is needle bearings. I have actually designed ratchet mechanisms and did quite a bit of research on designing a cable reel that was geared and you could ratchet the entire cable reel and it would actually prevent it from doing back travel. So when you're reeling it up, it would be ratcheting and then would stop. And then you could flip the ratchet and go the other way when you wanted to unwind it. And in that case, I actually did use some kind of, not needle bearings, but some pins that just simply lock in on each side. And that's probably what this has in there. It's about the most compact way. The catch is it's only as strong as this piece of plastic. If this piece of plastic expands, the bearings will skip. It looks like it might be glass reinforced nylon. It seems to be a nylon. I'm not going to do the AVE test of cutting it, but seems to be. I think it'll probably hold as much as anything you could do with a hand driver. If you start getting on this with a side profile, where you're doing something like this, then yeah, I don't know that it'll be able to handle all that. I have like I said, I have a smaller ratchet wrench that has skipped every once in a while. The good part news is that when it skips, it's like a gear skipping, and that they'll fall back into place here. I think you had another question about that before. Yes, taking apart your Leatherman if you're going to be replacing pieces is going to void your warranty. You can you can put it back together. So keep your original pieces. If you do any mods, you can put it back together. So let's say for some reason your file breaks in half. So if it's a Leatherman piece that breaks, they'll fix it, but not on a modified Leatherman. So you can put it back together and then send it in. That's entirely up to you. I do have warnings about that on my website. To me, it's been worth it. I haven't had anything break on here, and I use this a heck of a lot. I built my shed using a lot of this, so that's paint and drywall and all sorts of stuff down in there. Let's see here. If you're not sure, you can try printing on 3D printer, home printer. So yeah, what I actually do, I always prototype everything on an at-home 3D printer. Let me go grab something really quick. Oh, thought I had the parts right there, but they're in the garage. So I always 3D print these holsters on an FDM 3D printer to do a validation of kind of fit. I can't quite get the perfect fit because the tolerances are not down to 0.2, 0.3 millimeters on those 3D printers. But it gets me most of the way there. All right. So we fixed that dimension. Switching back to split screen. And visually it looks more correct. Now one of the things I can do here is to actually visually hold up the part, zoom the CAD out a little bit, and you can kind of double check your work as you're going along by holding the part and looking at the 2D profile. The reason you want to zoom out is that the further you get away from your eye, the less parallax effect you're putting on the part. And that's where you can kind of, when you're going along, and see, oh, did I get something completely wrong 10 minutes ago, like I just did. That's something I do quite often. We'll add the rounds and other things later. So now let's add the chamfer that is on this top edge. Um, so that's one that could probably measure. Might be just 2 millimeters. A little hard to see where the edge is because these pieces go over that corner. The kind of indents that are in there. I think we'll go for 2 millimeters. It looks right. And we'll add those in a little bit. We'll add the little notch, every little detail that we can visually see. And to me, it's kind of like if you ever took art when you're doing a still life, it's like what's on that scene that is not on the picture. What do I have left to do? And I find I do that quite often. All right, so for this one, I picked when I did this dimension over here, I picked this as the kind of knee before the corner of this, so I can just simply drop that down to 45. Again, I can just messily make that triangle, revolve it around the middle, do 360. I need to turn off the create live section view because I don't need that live section view. The live section view is really good if you're working on a hollow object or something that you need to be able to see the inside and the outside at the same time. I don't need to. Just because we're making it visually look right, we'll go ahead and grab an offset from this edge of just 0.2 millimeters. And we'll pull that in, grab this region, and we'll pull that in just 2 millimeters, make sure it's a cut, just so that looks like that's separated. It's actually fairly tight on the part, so maybe we'll go ahead and do that as 8.8. Pull that in just a little bit. Now you'll notice that it's starting to get very tessellated. And what I can do is go up here. So this literally got sharpness. So, fast display, but then it gets really tessellated where now I can set it to, it's going to warn me, but I'm running an RTX 2080, so it can handle the frames here. And we'll save. Get very habitual about saving whenever you're working with CAD. All right, so now we're going to start working on the hex opening. Now this is not going to be 6.35 because 6.35 can't fit in 6.35 millimeters. It's got to be a little bigger. So let's see what they did as far as tolerance. We're at, let's see here, maybe 6.5. It's a little bit hard again because it's wanting to twist on me. So I'm going to do it the blind method here. And I'm going to tighten my calipers a little bit so that they don't slip on me when I pull it out. Trying to get to the flats, trying to rotate this right so that looks like we're at 6.5. And it's again 6.5 divided by 2. There we go. And I don't care what the angle is, we're just going to pick 0. Now, the other difference between the ratcheting driver, switch cameras here, is that they have a magnet in the ratcheting driver where the bit extender had a spring up here. There's pros and cons to that. If you put a bit, like a regular 1/4-inch bit up here, if it doesn't have these little cuts in it, then let's see if all of these guys have, the ones I happen to pull have the cuts. If it doesn't have the cuts in it, it's maybe not going to grab quite as well. The magnets, of course, a little easier to drop in. But Leathermans all have those cuts, so they all stay in very well. The reason I say there's some cons to it is that eventually that magnet inside there is going to crack. And when they crack, they just explode into a bunch of powder. Magnets are not solid metal. A lot of people think they are. They're nickel plated, not even sintered, just compressed powder, like a pill that's been nickel plated. And the only thing holding it together happens to be the magnetism of the material. So every single time you're dropping a bit inside there, it is going to smack that magnet, and eventually, especially because you got a sharp bit on both ends with these guys versus a blunt bit with your regular 1/4 inches, you might end up a little hard to get that one out. You might end up cracking that magnet inside. It's not a huge deal when it happens. Usually they continue working, but sometimes you'll pull your pieces out and they'll have magnetic filings stuck on the end. The other con I don't like is that when you get to some of these smaller Leatherman bits, your magnetism is now holding this little tiny area instead of this big area. So sometimes these smaller bits just don't quite stick quite as well. In this case, it seems like they picked a fairly beefy magnet. It isn't falling out all by itself. You can see there is a little bit of play. That's simply going to be because of the tolerance. You get less play with these guys because you got more surfaces that are smacking into the edges compared to the flat bits where there's simply only these two surfaces that are snapping in. All right. So we are going to grab this hex. Back to split screen. And somebody asked a question. Okay, here. The magnets inside the P4, P5, P2 and P4 same size. Oh, well, actually, I should talk about the magnets inside the Free Series too. Now, I actually have a magnet inside one of my holders. So I actually designed. I had the idea to do this flat bit holder first, but it took about 3 or 4 revisions. I have the full design document, full design of me doing this on the multitool.org forums. But I also have the 4mm. Now the 4mm is a little better if you do electronics work, because you can get these kits like from iFixit that have all these different bits that are for precision. And so I actually designed this first, where it can take the 4mm bits, but it requires you to separately purchase a magnet and glue it in. And sometimes you have to drill out the middle. And so when people ask which one to buy, I always recommend the 1/4" guy because he's ready to go. This is how it comes. At most, you might have to drill this out and tweak the springs. And then you might be asking, you're also, I'm sure, asking about the actual magnets inside the Free Series. These guys up in here. The only difference is their actual height. They have the same relative dimensions, but they're actually basically held by the scales. So they're exactly as long as the inside of the scales. That's the only difference between them. In the case of this guy, it looked like they got away with a 1/4" long magnet or something like that. That a very comes out to a very common dimension, and they probably had to customize the P2. By the way, if you want to figure out which one to order, here you can see that the difference in thickness between the P2 and P4 is just not enough. Get the P4. You get you get 2 more tools, and then when you go to customize it, if you want to customize it, you got 4 options to put implements into instead of 2. The magnets inside the Free Series, by the way, talking about them exploding. Leatherman actually did. The tool has a 0.2mm gap between this flat surface and hitting the magnet. The magnet's held in by these little springs, so the magnets do not get smacked. So they will probably last quite a long time. The only thing that'll deteriorate maybe is the nickel plating, but you actually do use nickel plating for corrosion resistance, so it'll last a long time. But I'm most happy to see that they didn't allow the tool, when you close it, to smack into the magnet every single time. All right, switching back to split screen here. And let's continue. So we're going to pull in the hex. In this case, I'm using the bottom edge of the calipers. And it's going to go ahead and stick to the magnet. So where are we at? We are at 15.9 maybe. I always do measurements a few times. You kind of end up averaging it in your head. I think I'm going to go, let's see here. Or what is it in inches? No, let's go with 15.9. So that channel is 15.9 deep. Now that's going to affect where all your bits fall in, and I actually have 3D. I've made 3D models of a lot of the Leatherman bits, both for rendering purposes when I do the products, but also to actually design these kind of bit holders that go with it. So I actually drop all those kind of things in here later and make sure everything fits. Now they've actually chamfered the opening here, and we're going to try to figure out what that chamfer is. Instead of chamfering these edges, it's a circle because they did it basically almost like a mill. So we're going to go off to the side again here, and this time we're going to do a line, but we're going to symmetrically do a line. So 0 on our degrees, and we're going to try to optically measure that opening there. Coming out about the 8.7. So we'll go 8.7 in 45. Now in this case, I only need one of these triangles. I don't have to worry about cleaning up my sketches. And I can even do this all with the mouse if I want to. Don't have to switch over to a different tool. And I can type 180 or 360 actually, sorry, to add that chamfer in. And I get in a habit of deleting the sketches and things. You can still do, I should mention, you can actually switch over to ordered mode, and that changes Solid Edge literally into a regular old sketch base where you gotta pick your tool first, draw your sketch. But once you work in the synchronous mode, you don't really want to go back because it's just incredibly fast to do almost anything and change anything. So they rounded this top edge. In this case, I'm really just going to guess, almost kind of visually looking at it. There's a little bit of a flat, so it's not quite 0.5. It's maybe 0.4, even 0.3. Looks like 0.4 visually looks closest when I'm doing the comparing the 3D model just visually. And then because we're being every little detail, let's go ahead and try to get that magnet in there. I can't really tell what size magnet they use. I can kind of, with one eye, figure that looks like it's maybe a 4mm magnet. It may not be metric. Can't really tell trying to measure down inside the hole, right? Just by optically looking through it. In this case, it really won't matter. This is just for visual so that we have kind of a look to it. But in this case, all I'm going to do is a tiny offset and extrude those in. Let's go 6mm as a cut. And then magnets almost always have a round edge. And so we'll just do that, and now it looks like there's a magnet down in there. And we'll color this later so that it visually looks correct too. Save. All right. Sorry, I'm actually visually looking and thinking my chamfer is not. So I'm looking at, I'll switch cameras here. I'm visually looking at, sorry, it's hard to look in one direction and try to see the camera in the other. Where this peak is, the distance between this peak and the end of that chamfer, looking at the reflection there, I think it's too big in the CAD. And this is again where I can just grab that cone. And this is the what they call the compass tool. And I can literally just drag that right until it looks a little closer. So I'm thinking it's a little smaller, maybe 0.2mm smaller. This is getting into the weeds, but it works. It's what makes it so that when I do my final renderings, might as well have been from Leatherman's own marketing department. All right, last little detail is these 3 cuts in their side. I'm going to assume that they're perfect circles taken off of this edge. In this case, I can show you a couple, like another one of the things you can do that's a little cool with this is that I don't have to worry about where those are right now. I just need to worry about their diameter, and I can move them later. In this case, I'm going to grab the width. I'm going to, like I said, I'm going to assume that they're perfect circles off that edge, not something else. I'm getting 1.9. Later, I might break out right. I got the headset if I need to see closer. But for the sake of this, let's call them 1.8. Maybe even a little smaller, 1.6. Those are probably legacy features that were 1/16 of an inch anyways. So we'll drop 3 of them down here. And we'll try to figure out where this guy is off the center. So a second here, I need that. I said the dimension could be placed because I accidentally grabbed the round and not the flat when I was over here mousing it real quick. So I'm gonna try to eyeball where the center is there. Now I actually want to get this fairly accurate because when I design a holster for this, or at least when I did this guy here, I actually have a small little lip. Let me blow this up. So I actually have a small lip right here that actually locks into those and snaps. And if you don't get that nice snap, you don't get that nice tactile feel. Those are the kind of things that I have to prototype. And then this is actually held into the bottom here, kind of springed. I got to actually redesign this because it's a little tight. It's not going to fall out on you. But it almost hurts your fingers to get it out. But again, like I said, I'm going to have accuracy in order to have that work. All right, what did I say? 4.7? 4.7. Now for the centers, rather than measuring center to center, which means I'm having to eyeball the calipers inside this slot, what's going to be better, and I'll zoom in a little bit here again, is to measure edge to edge, because I can see that reflection better. So if I measure this top edge to that top edge, and I can assume that the spacing between that top edge and the other top edge is the same, and I'll go ahead and jump to the other line. So it looks like it's 4 millimeters. Sorry, I'm a little off camera here. If I try to get that in the middle right, now you got that much play. This also works very well if you're trying to measure from one hole to another hole. Don't try to find the center of 2 holes. Like same thing, even if I was trying to measure these little tiny dots, you can find the top edge of each dot easier than you can try to eyeball the center. Okay, so that came out to 4 and 4. And we'll resolve all 3 of those features. Revolve all 3 of those features. There's a cut, 360 degrees. Now the other thing I could have done is done one in a pattern. So actually I'll delete those and go ahead and do that. So I can do a pattern along this axis starting at that point. And a fixed distance. Oops, I did 1 second. I forgot to pick the right direction. Along that axis. Why does it not let me flip direction? Huh? I don't know why. Usually it lets me flip the direction of which way I'm going. I might be picking something a little wrong there. The other option is just to copy and paste, where what I'm doing is I'm hitting Control, dragging it 4 millimeters, Enter. If I did it as a pattern, then of course anything I change on this would actually change the others. But in this case, I just don't really need to. And it looks like when they center this, they soften these just a little bit, rather than do a round, which is going to, since this is such a tiny, tiny detail that's barely going to show up in a 3D rendering, I'm going to apply just the smallest little chamfer to break that edge. May go back and do a round now that I think about it, because no, I do have to do a round. Because it's a round to a flat, the chamfer is going to be off on the wrong angle. So we'll go ahead and soften those up. And this is another spot where I'm going to visually check, see if they feel like they're too deep or not. I think they're okay once I zoomed out. When I zoomed in, they felt like they were a little too deep, but they're actually okay. All right, next up, let's see which feature we want to do next. Guess it's really going to be the major cuts in the ratcheting mechanism. I actually wish they made these a little deeper. That actually might bode well for the durability. Like I said, the needle bearings inside are going to be dependent on this part. If they put more of a grip on there, that would also mean less plastic on the inside. So they probably actually did pretty good on that. So in that case, we're going to start with a sketch, and I'm not going to care about how deep it is. So what we're going to do at first is just get ourselves the profile we want to cut. So we're going to start. They basically take the cuts all the way out, but they also, it's a little tricky. So let me see if I can show on camera. So you'd think it took this cut and just went straight out, but you can see in the reflection that that cut goes over the edge. So that's gonna be a little tricky to do. I gotta think how I'm gonna do that. I gotta do this a little bit different than I was imagining at first, because that goes over that edge. In fact, what we're gonna do in that case is we're gonna put the rounds into here first. Sorry, switch over. So we're gonna put the round on this edge first, so that when we do a sketch, we can take it over that edge. It doesn't look like I got much of a round on it, maybe just 0.5 millimeter. And we're going to do this now from the side profile instead. So what we're actually do is going to grab these edges, and then we're going to offset them. Offset all three. Oops, I grabbed the wrong thing. Come on. For some reason it doesn't think these are connected, even though they literally are. There we go. Now, I don't know if the caliper is going to be able to pick in how deep this is. Looks like it just fits. I don't think it's quite that deep. 0.42s. Yeah, 0.3 millimeter deep. So let's go 0.3 millimeters in. Switch back to that side profile, and we're going to find where the end of the circle is up here, trying to come off this gray. See if I can find a spot where I can actually grab the edge. There we go. Like 5 millimeters. And since that curves over the edge, so how does that? It's almost like it just comes off at a weird angle like this. Let's actually grab a tangent of this and jump to let's try that. We can always alter it if we need. In this case, I am going to erase all the other lines. So I have just this sketch, and we're actually going to revolve this. Catch is I want the width here to be fixed so that I can radius that a little better. Like I said, this one's a little tricky, although they are fairly flat. So maybe that is not the right way to do this. Because if they're flat, then they're cut like this. So maybe this is the way to go. Doing these little kind of features, you gotta think about how the guy designed it, what his intent was. So we're going with, sorry if I didn't show that on camera, 1.7, which is almost exactly what I had there. And we don't need that tiny little chamfer. It's not going to show up in the rendering or anything. So if it's 1.7, then this curve is 1.7 divided by 2. We have that. Let's see here. Ask is, did you get your similar ratchet for $30? Well, I got this guy straight from Leatherman. I guess it was about $30, I believe. The similar one, I'd have to look up. It's probably about 25 or 30. It's all metal. I can maybe grab it later at the end, but it's in the garage. It might actually be in the shed because I've been building a shed for several months. A very nice one. Let's see. There's a little bit of a round in here from the injection molding process. And we'll add that, but it's got a fairly sharp, again, looking at having good light and reflections is very handy. It's almost like it's got a tiny chamfer at the top edge. And I don't want all these edges. I want, so cancel that. So instead of this chain, I want to pick the edges. I don't want it to chamfer the tangents. And this is where order of operations might start to matter a little bit when you're getting down into the weeds. So let's put that on first. And then this in second, and that'll look better. All right. Now I got to count how many are around. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 or 15 around. Let's see here. So go to our pattern tool, circular pattern, around center. I hate to count that again, but I think it was actually 15 around. Let's see, I guess I can visually tell by just looking and seeing if there's an exact opposite or if it lands in the middle. No, so 14 around. There is an exact opposite to each one. So again, this is where even though it's not sketch driven, it's got that pattern. I can go back at any time and change that pattern to any number I want. And we'll delete that other sketches we do not need. All right, coming along. Now we are getting to where something's got to match up. So we want to do the ratchet markings. And that's, so they obviously got their 0 mark on the same side. They got their Leatherman print. So we'll go ahead and do a sketch from this direction. This one I'm almost going to do visually, not necessarily the calipers. I'll probably get the length of the calipers. They just went in a little bit from each side. Actually, before I do that, I'm going to apply these rounds that are here. They're fairly small, a little bit more of a round on this guy. This one's almost razor sharp, so let's switch him down. So this is again where, even though I did all those rounds in one operation, I can switch to just changing this one round, and then it'll break it away from these. So now if I switch this guy, it's only those two. Those are the small little things that make Solid Edge just a joy to use. By the way, it doesn't cost, it's about the same price if you're on the subscription per month as it is for SolidWorks. So if you're giving SolidWorks a try, give Solid a try. I've been using it now for 5 years, and like I said, extremely massive, tens of thousands of components, including wiring. When I design things, every wire's in there, every harness, every crimp's in there, every resistor is inside the assembly of these electronic mechanical assemblies, down to the zip ties that hold it together, and that allows us to do the entire design in the computer before we ever build. All right, that's the last. I think everything up there is good. And we're doing the notch. So it's between these two. So what we'll do is go ahead and draw that line, then grab that center. Try to get this tiny dimension. I mean, it's I'm gonna call it 2. Nope, can't be 2 millimeters. 1.8. It's almost right to the edges of those chamfers. Let's call it 1.8. They might have even come right off the tangent of those chamfers when they or did a tangent off of them. And this time we're actually going to do a rectangle. I just wanted to really find out where that center point was going to be. So now I can grab 1.8, 0 degrees, and now I just need to worry about this dimension. And I don't even know if the caliper is going to get in here. Not really. So this is going to be another visual. Just trying to... If I want to, I can pull out my headset and get really down in there. I'm going to guess it's even just 0.6. It's pretty darn tiny. Now this is something where I can do a 0.3 millimeter radius and just go ahead and put the radius in ahead of time instead of doing the round operation later. Now that's in the middle of the part. No big deal, because I can just drag that sketch off there. It doesn't matter where that sketch plane was. And extrude this in. And then I can basically visually live kind of just... This one's going to be more just visually dropping it in. And I might even pull this in here. Just a tiny bit. But that visually looks correct to the actual part. Next up is the dots. So in this case, I'm actually looking at the reflection of these dots, right? So that's where I was going, okay, these are flat because they have a very flat specular reflection. This little dot looks like he's kind of flat inside too. The funny part is that those guys look like they're round, but the reality is we'll probably never notice this part. Is these things are such tiny features. So in this case, we might just do this visually because it doesn't really matter. I just want to be on that center. Let's come up and see where these might be. It looks like they're 2 millimeters up. So there's a circle at 2 millimeters and a circle is 2 millimeters. Now triangles might be a little bit tricky because I can't cut them in the same way unless I twist the sketch, which I can do. Yeah, we'll do that. Let's just extrude him first. Now in this case, I actually drew him on this surface. We'll cut away in both directions and we'll just make it as deep as that so it looks visually like it's on the same plane. Come on. So I'm snapping to that edge. Is that not quite deep enough? Come on. Nope, not quite deep enough. So I'll go 0.15. It'll look visually correct. Now here's something I can do that's kind of cool. That gave me a flat plane, right? So now I can grab that, rotate it as a copy. And where am I at? Where's my dimension? There we go. And I'm going to say, oh, well, one thing is, all right, this guy's needs to get rotated. This whole feature set. Because these line up with the circle. No big deal. Grab that, type 90. Done. That fast. Imagine doing that if you had to go back to your sketch, go back to your pattern, go back to referencing some silly sketch of where the direction was. Can't do that. All right, so come on. It's a little bit tricky sometimes the copy operation because it just it flies off. It's relative to your mouse. I'm going to almost do this visually based on where the end tangent is. It almost looks like they did not necessarily an angle, but it looks like they did the triangle off the tangent of one of those guys. So let's just go 25 degrees. And I'm going to mirror him to the other side. And I'm actually going to break that mirror. Actually, no, I don't need to break that mirror. I can mirror this later. Never mind. So now they gave me a flat plane that's already ready to go. And like I said, it looks like they came off the tangent of this. So what we'll do is we'll come off this, off our center, and reference those 2 points. And we'll draw our triangle. Let's assume our triangle is 2 millimeters, same as the circle. Let's assume it's a 60-degree triangle. Now what I can actually do here is, even though that sketch is stuck to that feature, I don't need that feature anymore. Sketch didn't disappear. I can just cut it out. Now I have the triangle. And now I can mirror that off of this plane. Don't need that anymore. And did they round these triangle corners to make it more injection moldable? It seems like they did. So when you make the injection mold, it's typically being made by a mill, and although it's inverted, so technically you can't have sharp corners, but it's usually a no-no in all plastic molds. Just give it a tiniest bit. Now here's gonna be something cool that I already have from my accurate renderings, is I have the Leatherman logo. Look, I made them a lot of model of their most basic product. I think I did this for a rendering. I don't think I actually designed anything around it. But I can grab the actual geometry, bring it in here. It might end up being the right size, probably not. Let's see, I want to make sure that my rotation is on an axis that I know. 90. I want it to be lined up there, that's right. Grab the compass, bring it over here, switch the compass axis. Rotate that another 90, wrong 90, go 180. So, and then I can bring that up over here. It's buried, so let's grab this top edge. So I'm hitting a shortcut that lets me grab a feature by a certain spot. Now that's off angle. The bruiser's at a weird angle, and I think that's what it came from. Or boozer, that's what's called. See if it's off by 2 degrees. Looks like it's off by 2 degrees. Now, this is a little too big, right? So we'll just scale it. And actually first what we'll do, because I can scale the whole body. So this is kind of like geometry that's all alone. It's not actually attached to anything yet. And so what I might actually do is go ahead and attach it first. Let's break that mirror. I don't need that. So you see, just literally grab that geometry from a completely different model. Now it's already in here. I'm gonna try to figure out the best way to rescale this. I can actually scale the entire body, copy it out, and paste it in. I think what we're going to do is actually scale a sketch instead. So let's go ahead, and I undid the cutout. And let's hide this, and let's just grab all these letters. When there's 2 faces, it's going to ask me to do both. So all I'm doing is copying this geometry up to a sketch. The little S's that are in there means that it's tied to this geometry, but it doesn't actually necessarily have to be. Why are you not wanting to do? Why are you not want to project the N? There it goes. Hide that face. And now I can scale the sketch directly. So in that case, let's give us a reference point. So this is how you do relative dimensions in CAD. So let's grab this edge and this edge. And that gives us, whoops, that did not go straight. No, it did go straight, just my camera twisted on me. Okay, so we got 16.86. Now what I'm going to go do is go to the part and measure how big this is supposed to be in the end. Let me try to get in camera here. 14? 14. Let's call it 14. So all I really need to do is grab this sketch, scale it by a scale of 14 over 16.86. It's 0.83. There we go. Done. That fast. Now I can move this sketch. I'm going to assume they got it dead center, so let's try to find something that's got a line in the dead center. Fortunately, it's because it was a font, there's very few actual center lines, so let's make some center line by going up to here, out to here. Now we know where a center is. So I'll grab this whole thing from here, grab a center here and jump it up. And then it's fairly close to the end of the part. .5 from the end. So I'll give myself a guideline, come in 1.5. It's harder to hit a point, so we'll give it a spread like that. From here, and I'm just moving it to the right until it's close. Now I can grab all of these. The cool part is that they're already got regions inside them ready to cut. Extrude that in. Let's go 0.2 millimeters. I don't need these old sketches. I don't even need the sketches for the font. And last little bit of cleanup was we were going to go try to round these guys a little bit better. So let's apply 0.2 round to each of these. Let's see. Let's try it. I need the chain. There we go. I kind of did these in wrong order. The other thing that the synchronous lets you do is just willy-nilly delete things without worrying too much about how the order of how they were built. Not liking the way this is working out. It's a little tricky when you get corners that meet up like that, right? How do these corners actually meet up in real life? And it wouldn't have a feature like this. So actually, we're going to go ahead and delete. We're going to leave all those sharp corners. It won't really matter. Just trying to make it visual to the actual part because of the casting process. Still might add these in. It's these corners that are getting goofy. If you ever do CAD, you know that corners just start to become a nightmare when you get to the ends of some parts. Some CAD programs, even this will like just straight up crash sometimes when you get into too complex a geometry. All right, Probably don't have to really worry about it. I think, let's look at the part. That should be all the geometry. Now we really just got to paint it. And then I'll actually render this, make a photoreal rendering using a KeyShot. So here's some cool things I can do. I can tell it that it's made of steel, and it'll have the correct mass minus, a little bit of the plastic. But that steel color I don't really like. We'll tweak that. We'll first apply a gray to the ratchet. Now, I could have made the ratchet a separate body so that I could rotate it and manipulate it separately inside KeyShot. In fact, let's go ahead and do that. Let's show you how easy it is to do that. So right now, this is all one design body. So what I can just do really easy is copy this off like 10 millimeters up. It's now a, whoops, I did not copy the second body. 1 second. Let me add that second body first, then copy this guy. Give ourselves a little more distance so it doesn't try to merge them. It's going to be a little bit slow because it's literally recreating every single thing. And then since we have patterning, I'm going to keep the original body be the ratchet piece so that that pattern stays there. In fact, the pattern got deleted when on the second body anyways. Okay, so I'm going to activate this body. Let me go ahead and switch off to just solid edge since I'm just doing this right now. There's no base feature. That means for sketching basically, and I'm just going to delete all this geometry that I don't need. Oh, I said I was going to do it the other way around, didn't I? Good thing there's an undo command, right? Okay, so let's delete the ratchet. Let's assume this goes all the way through. Now let's go back to this piece. Now I move this up by an exact number, 20 millimeters, so I can just drop it back 20 millimeters. Hide that one though. And let's do just the ratchet. It said I couldn't delete the axis because you can't delete your axis. And we'll just cut this all the way through. So now those are two separate bodies. So when I go in, and I'll actually name this, so this is going to be the ratchet extender. And we'll call this just the plastic. All right, now let's change the colors a little bit. I can do this in KeyShot, but we'll do it in here so that if I do anything, it'll kind of look right. So we've got styles in use. We're using gray, black. I don't think silver's actually getting used. We're looking at the gray part first. And let's go ahead and it basically got a little bit of blue-gray. So let's just bump the blue up just a hair. And the overall darkness down. That's probably close enough. Switch over. And we'll just adjust the steel color that's already there. It's also a little too, oh, let's see here, steel. It's a little too shiny. So bump the shininess down, reflectivity down. And just bump the overall color up. All right, now what we can do before we go to render this, let's go ahead and add a couple parts that'll make the rendering look nice. So we'll create an assembly using this part. I guess I'm going to stick with metric for now. I'm going to jump over to my folder where I have Leatherman bits and just drag those in. See if I have anything else that would go well with it. I have 4mm bits. Yeah, nah, we'll just stick with this for now. This will be really simple. And then this is an assembly, so I can, whoops. Yeah, I do want to save this assembly for right now. And this is my render copy, basically. And I'm actually not going to create a new part right this second. All right, so I'm going to mate him to the magnet. And I'm going to find his center because he's already got a center. So I just need to turn his axis on and assemble the planes in the axis to the planes in my assembly. It'll be perfectly centered. As long as the hex is in the right orientation, I guess. Where are we at? Here we go. One thing you do is you mouse over and you can find the things that are hidden behind other things. And we'll hide all the axes we don't need. Oh, you're not seeing the drop-down menus? I'm sorry. Here, let me switch over. There we go. I did not realize that. Oh, you aren't even seeing the tree. So I had OBS set up to render just solid edge, so you didn't see like my folders and things like that. I'm sorry about that. I did not realize looking at OBS that it actually hides even the tree. Was it hiding the feature tree the whole time too? I'm curious. Yes, it was. I will have to remember that. I'm so sorry. Thanks for letting me know. All right. Oops, what happened to our Bert? He just disappeared. Let's close that. I want to go ahead. Oh, I don't need this. Let me reopen that file. All right, we're just going to go ahead and render this as it is right here. So key shot. Make sure that that's rendering. That's visual for you guys. It is. All right. We're going to give ourselves a little bit larger resolution to work with. Give us a 720p picture. So Keyshot, if you don't know, is a rendering program that is basically based on the physics of light. You can do some incredible photorealistic renderings when you get down into kind of the details on this. We're going to do something kind of quick and dirty. So first, the part's standing up. We don't want it to be standing up. Oh wait, actually, first I need to make sure my scene units are set to millimeter, which it should be. That's if you do real world parts. You want to make sure your units are correct. So one of the cool checks you can do to see if your units are correct is Moldtech. Moldtech is actually a company that makes the. They actually make the texture that is inside a plastic mold. So a company that actually makes a mold will make it to a perfect mirror finish, and Moldtech will go in. So my scale's off. Something's off here at the scale. So let's undo the scene units and see if this looks correct. There we go. And so you'll actually literally kind of almost recognize some of these molds if you ever look at a car dashboard or something. And so these Moldtech parts have an absolute fixed dimension to be correct because they're branded. And so they're my check to make sure my scale is correct. Because if it doesn't come in looking like this, then it's not right. But the scale's correct now. So now we can go in and grab a plastic, a black plastic. And actually, I might have a nylon, which would be more accurate. I do have my nylons. These are my 3D printed nylon textures, but we'll use those as a starting point. So we'll bring in the texture window. Let me split this a little bit. Actually, let's just dock him. And in this case, it's a very flat. So one of the things I could have done is, you know what I need to do? If I want to make a really accurate rendering, because there's a texture on the outside of this part that is not on these flats. So real quickly, I'll go in and just paint him a different color. I'm going to pick something silly with a high contrast that I don't really care about. And we'll paint this, that. I don't want all the rounds, so maybe actually it's going to be better to paint the body that color and then the faces back to another color. Because it's these faces. These faces do not have any texture on them. And if I want it to look accurate, that's what it's going to have. I'll fix those other couple of missing pieces. We'll just do this real quick. So how KeyShot works is it's taking these colors basically, and it's going to split the model into those pieces. It actually doesn't necessarily follow the 3D geometry as much as it follows the colors that are used. And come on, that round. Oops, wrong one. Red. And I can go back later and fix this, the actual model to look a little more correct. And those are red. So bear with me for a minute here. It's easier to paint all the colors and then paint the one surface back. And I don't think there's any difference for all the metal. The metal is probably gone through a bead blast finish. Oh, but we ought to change the magnet so that if I do a rendering showing the magnet, so we'll just pick a silver for that. And I'm going to try to get that little face inside, even though it's never really going to be seen. And then, so I'm looking at the part here to see if there's any other textures that I want to change. The inside of the hex has a little bit of a different texture too, so let's just pick yellow. Go ahead and pick that internal face. That cylinder, there we go. Okay, so that should be all the different textures we actually need. So we'll go back here and we'll actually update KeyShot. Now it's going to pull them in as really funky textures, of course. Let me save that. Go back to Solid Edge and save. But that's just fine. So now we'll bring in, let's go ahead and bring in these two guys. And we'll edit this. So I have a plastic material already, but now I want no bump on that at all. I don't mind the specular, so bump mark is going to affect the way light bounces off. Specular is going to change kind of the angle that light refracts, or not refracts, but reflects off. They're related, but a little bit different. You can actually get some very nice metals by not changing the bump, but changing the specular, especially if you pick an anisotropic material. And that's what I did on the Leatherman when I did the rendering back here. So when I made this rendering, what I have is, there's actually probably about 5 or 6 different metal materials inside there. Switching back to desktop. That's all it is. And this already is kind of a blue, so let's just go ahead and adjust the blue shade. Now, if I want to get really detailed, here's what I could do. I could grab a picture of the Leatherman Ratchet and pick the color right off of it, but I think this is getting long enough, so I'm not going to go do that right now. I'm just going to tweak it till it looks about right. That is something I would do if I was trying to match a product, a specific product, like we're doing this project. Whoops, what happened there? Give me that blue back. Now I'm actually going to copy this material, paste it over here, but it's paste as a copy and that bump map is still disabled. So now I can turn that bump map on. It's not that high. It's a very fine finish, and it's almost, and it doesn't need the specular map. Specular kind of is going to make it look scratched, which we don't need to do. Still got this color too blue. So that was 11%. We'll go back to here and go back to 11%. Okay. Now we're going to grab a steel rough. And let's see, you know what, regular old rough steel, not anything else. And then that's going to be, of course, way too reflective. So I'm going to try to figure out why my camera's not orbiting here. It's doing something funky. It's in tumble mode. Oh, because I'm looking at the part from a weird angle. 1 second, let me change the camera. Delete that. By default, it pulls in an almost a ridiculous kind of camera angle and twist. That's what's happening here. And then that changes all your orientations. We're going to grab this part and we're going to lay it down anyways. So you can rotate it, snap it to ground. Let's rotate it so it looks like it's sitting naturally. We want the Leatherman logo up, maybe a little at an angle. Snap to ground isn't always perfectly accurate, and we are going to move this relative to ground. Where's my axis? There it is, global axis. And you can kind of see when it clips through because the shadow disappears. And that's where you can kind of tweak it manually. All right, looking at chat real quick here. Thanks for the compliments. And Jericho, cool. Delivered last night, good. Unfortunately, Shapeways is a little slow sometimes. Oh, what happened to those purple ones? Why are those a different? So I'm going to alt click on him. So he got pulled in as a different color. Interesting. All right. So we're going to copy material. We're going to paste a link to material. So any changes I make to one are going to copy to the other. Does this still have the bump map on? It doesn't. It's got a little heavy specular and it doesn't have enough gloss. That's what's happening. There we go. Now that's looking like regular old injection molded plastic. And the specular, we're going to lower the contrast a little bit so it looks less like scratches, more like plastic injection mold stretching. All right, back to our steel. Drop the gloss. Gloss is going to be kind of the micro reflections or the micro. It's an even distribution of how light spreads off of the surface. If you put it at 100%, it's a mirror. Like I said, because it's physically measured, they can actually physically measure this. In fact, there is a measured metal. So if I pick measured metal and I pick iron, it's actually pretty darn close. We'll just drop the gloss down. I think that's actually good enough for what we're doing. And then I actually think I have a black steel. Nope. It's on my computer at work. Not talking to you, Alexa. So in this case, we'll actually leave that. I like the color that it is and change the material from plastic just to metal. And that'll probably look pretty darn close. Now, because we got stuff on the inside, I'm not going to worry too much. So we'll go to the scene, we'll hide our bit so I can see inside there. Oh, got a dog marking, sorry. Let's grab some nickel polished, maybe nickel rough. Nickel rough looks more close to it. And we'll again copy this material, we'll paste it here, but not as a linked material, and we'll just up the gloss a little bit because it's like they kind of ground that area a little bit, but otherwise it's the same material. All right, and then this is my material library of things that I've done. So see, the only one I haven't done, I guess I have edited. So I've edited all the materials. So that basically gets the render. Now I can output this with much more detail to it. If I want to, I can now, that bit, I want to rotate him. So it just looks a little more visually correct. I rotated it along the wrong axis though, all along his local axis. And I'm holding shift, which is going to snap him to set angle so I can make sure he stays inside the hex. The last little bits we're going to do is adjust the environment. There's lots of environments that come with the software with KeyShot, and there's a lot you can download as long as you got a valid license, which I do. This is actually not the full version of KeyShot though. This is actually the CAD version, basically, that they provide with Solid Edge. And then I'm going to change my ground size to something smaller. Your ground size affects the precision of your shadows, because it seems like they have the ground as almost a fixed texture map that they render it onto. So if I want those shadows to look really good, we'll rotate our scene a little bit to get just the right reflection off of those specular highlights. I think I'm going to go in, see if I turn off the specular. It needs to be there a little bit, but still needs to be less contrast. Again, I'm getting into a little minutia, but when you want something to look absolutely photoreal, you got to kind of look at the little tiny things, like even the gonna twist the angle on those a little bit so they're not perfectly in line, so they look more like mold marks. And that'll do it. So let's go ahead and save this. And Leatherman Ratchet. And then you can render this off as a JPEG. You can do all sorts of stuff after that. You can animate it. But we'll go ahead and do a nice, let's do a 1080p for the sake of speed. And even though that it kind of updates back here, when it does this rendering is when it's really getting into the mathematics. You can tweak this to ridiculous degrees where you can do caustics and all sorts of stuff. We don't need that for this. The only thing I do notice is that bit is way too. Something's wrong with it here. What do we got? Maybe just bump the gloss up. That bit's a little too perfect for the render. So let's add some scratches really fast. So we edit the material. We'll go ahead and we'll add them as a bump. Scratches is built in. By default, it kind of just wants to make things look like scratch glass. We just want tiny little ones. And want more noise, more levels. And we're actually going to copy that over to, what's not the color? Oh, that's right. This is going to have a specular. That's not going to work as well. Let's go back to a regular texture. Just go straight up with the scratches texture. Just want it. That's a little better. Again, barely scratched. Let's unlock the aspect ratio and stretch them because it would have been on the way in and out. Make sure the color's off, and it just needs to be now a little less glossy and a hair darker. I should be saving my camera, so when I do a render, I can actually do multiple passes. So we'll go ahead and do that. Camera saved, render, done. So Jericho asks, yeah, it wasn't too bad, thankfully. He's installing his bit adapter. I'm not sure what to order from the Shapeways store for my P4 next. I've been really enjoying the scalpel holder because one, I can get these blades that don't have the razor sharp ends. So the blade is razor sharp. It's literally the same as this blade, but they just dull the end. I recommend that because this can pop up on you. There's a little bit of play in the free system. This is not just because of my design. You can see the scissors do it too. But I like it because when this gets dull, you just simply take it off and replace it with another one, and they only cost like maybe $1 each blade. That's been my favorite. It also only it replaces the blade directly, where if you do the T-shank adapter, you got to remove one of the small implements because of this extra thickness, and you also need to order your own screws and do some tapping. So the T-shank adapter is quite a bit more complex. You got to trim the end of this. But the scalpel blade holder is just remove your blade and replace it with this guy. The most you have to do is clean up the little inside edge on there. That shows on the video. And then the holster, if you want. Uh, I carry this on my belt every day when I'm at work. I use it all the time for all sorts of stuff. Having hex and Torx bits right on the back is really helpful. I'm trying to remember what I used it for last, but you can see that it gets plenty of use. And this has been cycled. I mean, I fidget with this, right? This has been cycled thousands of times and it still works because I used the springs and not some metal clip or a piece of plastic that was going to expand over time. All right, so we're going to jump back to our render here. And this is basically going to be it. That is the entire beginning to render of the ratchet. Now, what I'm going to be doing with this 3D model is I'm going to be designing some probably its own standalone holster. I want to design something that that basically holds this guy and probably in a round profile or half round profile some bits around it so that you can pull this out, pull the bits off, and get them ready to use with regardless of which tool you have. In fact, I might even try to figure out a way to make it be a handle at the same time, where you could pull this off and dock this and then use that as a handle. This is nylon, so it should be strong enough to handle that if I have the right bulk. But I think that would be the best thing. I've had several people ask for standalone bit holders on their own, or even holders that hold these guys, since these are just loose. They made them to throw into a toolkit, and they put a little lanyard loop on the top. But if you want this hanging, these are all gonna catch, especially this guy. So I was gonna try to design something where like this guy, these can catch a little bit, some of the sharp ones, but for the most part, I mean, I'm rubbing my hand on here, and all I'm feeling is maybe that one, uh, because the body of the tools is stopping the edges from getting caught. And that's kind of what they tried to do by making this have a big flat. So maybe if you just take him out, he's okay. But that's what I'm going to be using this 3D model for, is to design some sort of holder for this. I've already had, like I said, people request to see if I could get it onto the side of the tool. It's not going to go on the default. I might try to see what I can do to fit him on the side of the holster, but it's going to end up having to push this out, which of course makes it more fragile. And also, this guy pulls up and through here. This would have to pull up and then out in a weird way, so it's going to be really tricky to get him integrated in the holster. So I'm going to work on its own standalone product at first. But I think I've already had 5 or 6 people ask, and it's like, oh, I just ordered it, I just got it today, things like that. It's been I think it's a really cool product for them. It is pretty much the smallest ratchet mechanism that I've seen as far as completely standalone. Um, and if you're coming in late, like I said, I mentioned these are needle bearing, so it's going to depend on how strong this piece of plastic is. You can kind of see it bounce a little bit when you twist it. So it is relying a little bit on the springiness of the plastic. So we'll see how long that lasts, but I believe this is glass reinforced nylon, at least nylon, so it should last quite a while. I think it's a really cool product. So thanks for joining me for this kind of, whoops, got the wrong darn screen up here. This whole 3D model, and you kind of see how you can go from nothing to something as accurate down to the font. I'm not sharing the secret of how I got that font, but I basically extracted it from a data sheet. But there we go. Thanks, folks. I'm gonna be stopping the stream now, and you guys can watch it again on here later if you're just catching up. Thanks for joining me.